Working with rasters is similar to working with vector data in SpPy. So I'm just going to go ahead and copy and paste some additional code down from the website. Here I've set up a Python script just with the same stuff at the start. And I think I added GDAL is the only change that I made. Just need to import that. And you can see that here we do the same type of thing. We just create a raster data set from the rasters module instead of a vector one. And then we can load raster data into that. And then once we do that, we can get the width of the raster and the height of the raster in pixels. So it's a nice little raster. The number of bands, 1. The projection, so here's the really spatial reference is what I really should be calling it. WGS84 UTM zone 10 north. And then the resolution is in UTM, so the units are in meters, and this is 1:1 data. This is the LiDAR from Napa County, so very high resolution. And we can also get the bounds of the raster, and just note that that is X-min, Y-min, X-max, Y-max. So just remember that's the format for that because that's how it expects those numbers to come in or go out. And then we can go ahead and save that as a copied raster or a duplicate of our raster. And I delete those and run this script. And you can see that it's pretty quick. And there's our duplicated raster. Okay, moving on. We can also create a new raster. So if you wanted to make a raster with certain characteristics, width, height, etc., you can just specify the width and height in pixels. Then you can create the raster data set the width and the height, set the type. These are based on GDAL definitions. So there's float, int, a whole bunch of them. Different ones are in here. There's a lot of definitions in here. There they are. And then we go ahead and allocate the arrays. So this is going to allocate inside memory a array of the bands for the raster, which will be returned, and then we can grab the first band. And each entry in the bands is actually a two-dimensional array with the rows and columns for the pixels in the raster. And so this code then goes through each row one at a time until it hits the bottom. And then same thing for going left to right along each row, and sets a value into the row and the column, giving it the column number. And then we go ahead and print that out for some reason. There it is. So there you can see our little grids being created. And then we set UTM 10 for the spatial reference, set the northwest corner, the resolution, I'm saying this is 30 by 30 meters, and then save that as a new raster. So we've got a new raster with a line going through the middle of it. Just as an example. There's a bunch of transformations for rasters. There is a reference at the bottom. I'll just show you one of the key features here is that you can either take a shapefile or raster data set and call a function like less than. This is in the STRasters module. So this will return a raster with ones where this raster is less than 10, zeros anywhere else. There's also greater than, less than. Again, they're defined at the bottom of the web page. And this comes back as a new raster you can save to a file. If you want to work with data sets, especially if you want to do operator overloading, if you're doing a lot of raster math, this looks a little better. You can create a new raster data set and load it in, or if you've already got one existing, you can then go ahead and do raster comparisons and arithmetic and Boolean operations, getting back again a new raster, and then you can save those out to a new file. So here, if I go ahead and run this, we get a raster where the values are less than 10. Okay. Using the proj library, SpPy has full support for a huge number of spatial references. We use the proj4. If you go to proj.org, their website, you will see the definitions for the projection. So in this case, this is Albers equal area. And we use the proj parameter definition. So latitude 0 is 0, latitude 1 is 60, longitude of origin is 0, latitude 1 is 60, latitude 2 is 40. So these are the parameters used for Albers equal area. In this case, because I've got UTM data, I'm actually going to back project it to lat long, and that doesn't have any parameters. And then here, GDAL does require the raster data to be on disk. So here we've got a function where you actually pass it the output path. And along with the raster you want to project, the code, the parameters, and then the path to save it to. So here we've got our projected raster. Okay, and as I said, there's a bunch more functions, but lastly, I will go ahead and let you know that we can also render data to rasters. Now, this is definitely a newer part of the code, and it's definitely still a work in progress, but it's getting there. And the idea here is that we've got a data set that we've loaded. We can get the bounds for that, and then we create a view from SpView. That's the module, and the class is also SpView. We say we want it to be 500 by 500 pixels. We can set the bounds for that, and then we can go ahead and create a layer. So the layer is equivalent to a layer in a GIS package, where the data set is equivalent to a file. The layer will have the ability to change symbology in the future. And then you can go and render the layer to the view and then save it to a folder. And there it is. All right, and I hope you enjoy it, and let us know what other features you'd like to have and what we'd like us to do with the documentation, and if you want to participate in extending it. Thanks.